students, in this lecture we will continue with the greedy algorithms, and the problem which we are going to discuss is job sequencing problem. So what is the problem? Here you are given an array of jobs. You have a number of jobs. Suppose J1, J2 and Jn. These are the jobs which are given to us, and each job has a deadline. Suppose 8, 2, then 7. So each job has a deadline. These are the deadlines. That is the time before which these jobs should be completed. And each job has an associated profit, and the profit is earned if the job is finished before the deadline. Okay, suppose 100, 200, 150. This is the profit. Okay, job 1's profit, job 2's profit, and so on. For every job we have a profit. And here we take an assumption that each job takes a single unit of time. Okay, so there is a single unit of time each job requires to complete. Okay. Thus the minimum possible deadline for any job is 1. Why? Because each job takes a single unit of time. So suppose this is Ji, so the minimum possible time or the minimum possible deadline for some particular job Ji, it means it is 1, right? So 0 is the time from where we start executing these jobs. Okay. So what is our objective? Our objective is to maximize the total profit if only one job can be scheduled at a time. So it is not possible that at the same time you are executing multiple jobs, Ji, Jj. Okay, so only a single job is possible at a time. This is the first assumption, and the second assumption is that each job takes a single unit of time. So let us take an example. We have 5 jobs, A, B, C, D, E. These are the jobs. Deadlines, these are the deadlines, and these are the profits. Now what is our aim? Our aim is to maximize the profit. Okay, so how should we pick up these jobs so that we get the maximum profit? So this problem has a particular solution, that pick the jobs C, A and E to maximize the profit. Okay, so let us look at this problem more deeply. So job A has deadline 2 and the profit is 100. Okay, so suppose this is our timeline, and here we are starting. This is 1, this is 2. So A must be completed before this time, and if it is completed then we will earn the profit 100. Then we have another job B. B's deadline is 1 and its profit is 90. Then we have C. C is giving us a profit 27 and its deadline is same as that of A, that is 2. And we have another job D with deadline 1 and the profit which it is giving is 25. Okay. And we have another job E whose deadline is 3 and it is giving us the profit 15. Okay, so it seems that A is giving us the maximum profit, so it must be picked up. Okay, so we pick A, and if we pick A, it will give us a profit of 100. Okay, so the time slots in which we can schedule it are 1 and 2, right? Because its deadline is 2. Okay, and then the next job, the next highest profit giving job is C, right? C is giving us the profit 27. So its deadline is also 2. So the slots for this can be 1 or 2. Okay, so suppose we schedule A at slot 1 and C at slot 2, right? So the total profit which we are earning is 127. And then can we schedule D? Here we have D, and D's deadline is 1 and profit it is giving is 25. So now we have already filled the slot 1 with job A, so we cannot schedule D, and moreover it is giving us a lesser profit, so there is no use of picking D. Similarly, if we look at job B, then the profit it is giving us is 19 and its deadline is also 1. So again slot 1 is filled and the profit it is giving is lesser, so we will not pick B. But E can be picked because its deadline is 3, which is not colliding with any other job, and so we can earn this profit of 15. Okay, so I think this is the total profit which we can earn using the sequence of jobs CAE. Okay, so this here in this example I use the sequence ACE. Okay, and it is saying that you pick up the jobs in the sequence CAE. So how does this sequence come? Although the profit is same, whether you pick up A before C or A after C, the profit will be same, but the job sequencing problem has a particular algorithm, right, which we will discuss shortly, which will output these jobs in this particular sequence, right? So now let us look at the algorithm. So the algorithm is saying that sort all the given jobs in decreasing order of their profit. Okay, so first of all we have to sort the jobs such that the job with the maximum profit is at the top. Okay, like this. So here if 2 or more jobs are having the same profit, then what to do? Suppose there is a job A and a job D which are having the same profit, then what to do? How to sort it? Then sort them as per their entry in the job list. Okay, so we have to preserve the order. So A is coming before D, so in the sorted order A will come before D. Then the next step is iterate on jobs in decreasing order of their profit. So we will iterate on these jobs, we will pick one job and do the following. So what we have to do for each job? Find an empty slot from deadline to 0. Deadline means deadline of that job, the particular job which we have picked. Okay, so for that job, suppose we picked job I. Okay, so it has a deadline D. Okay, so this is the time, so we have to pick an empty slot starting from the deadline of that job to 0. Okay, so if there is an empty slot, then we will put the job in that slot and that slot will be marked as filled. Okay, so now we will see how this algorithm will work using an example. So this is the example, this is the same example which we discussed, but now this time we will discuss it with the help of the algorithm. Okay, so sort the jobs according to their profit in the descending order. So first of all we will sort them. A's profit is maximum, then we have C, then D, then B, then E. So we have sorted them. Then find the maximum deadline value. So out of these jobs we have sorted them in the order of profit, which is the job with the maximum deadline value. Okay, so here we see that the maximum deadline is that of job E. Okay, so E job has a deadline 3, which is maximum out of all these deadlines. It means how many total slots we have. So this is the time, the maximum deadline is 3. It means we have 3 slots, 1, 2 and 3. Okay, so these are the total number of free slots which are available to us. So here it is, slot 1, slot 2, slot 3, and initially we have not assigned any job to any slot, so all the slots are empty. Then we have total 5 jobs, right? And so now we will start iterating over these jobs. So first we will pick job A. Job A's deadline is 2. So what the algorithm was saying? The algorithm was saying that start from the deadline of the job till 0 and find a free slot. Okay, so starting from 2 to 0, we have the empty slot at 2. So we will put 2 here, right? So we have put 2 here. So slot 2 has been occupied by job A, right? So we are done with job A. Next we will pick job C because it is next in this iterated list, right? In this sorted list in the decreasing order or descending order. The deadline of job C is 2, right? But the slot 2 is already occupied by A, so the next free slot going backwards is 1. So this slot will be filled by job C. Okay, so now this is how our this time slots look, right? Okay, so job A, job C, these are done, and the next job is job D, right? Job D's deadline is 1, but we do not have any empty slot here at time 1, so we cannot schedule job D. Okay, next we have job B. Job B's deadline is also 1, but we do not have any empty slot starting from deadline of job B till 0, so we will not schedule job B. And at last we have job E, and job E's deadline is 3 and we have an empty slot at 3. Okay, so we will put E in the slot 3. So this is how the output CAE is got using this greedy algorithm, right? So now we will look at the pseudocode for this job sequencing problem, and what are the inputs which are given to us. We have n number of jobs and we have an array D which contains the deadlines of all the jobs. We have an array P which contains the profits of all the jobs. So first step in this algorithm is to sort the jobs according to the value of profit. Okay, so we will sort the jobs in the decreasing order of profit, right? Then next we will decide how many time slots do we have, right? 1, 2, 3, as in the previous example we had 3 time slots, and D max means the maximum time slot. Okay, maximum deadline we can say. So this maximum deadline or the maximum time slot is maximum value in the array D, right? Then now we have the maximum deadline, so we will create this kind of array. This array is called time slot, and it will contain the values starting from 1 to D max, right? So it will contain D max number of time slots. Okay, so in the previous example D max was 3, so it had 3 time slots, right? So now we have the time slots. Now it is time to fill these time slots with the jobs. Okay, so we will iterate over all the jobs. So it means we need a for loop, and it will start from the first job till the last job, right? So I is initially 1. It means we are picking the job with the maximum profit, right? So here we create a variable k. K is equal to minimum. Let me take an example to explain this. So in the previous example, let us say I is equal to 1, right? It means we are at the top of the array. At the top of the array we had job A, and the job A's deadline was 2 and its profit was 100. Okay, so this was the scenario. Now K is min of D max. D max is 3, that is the maximum deadline, and DI is the deadline of this job. Okay, so it means K is equal to 2. Okay, so we will start from 2, that is the deadline of that job, till 0. Okay, so while K is greater than or equal to 1, so we will start at the deadline till the very beginning, very first time slot, that is the time slot 1. Okay, so going backwards we will find whether there is a free slot or not. Okay, so we are checking the time slots here. So first we will check whether time slot 2 is empty or not. If it is empty, then we will assign the job I. So I is 2 here, so we will assign the job I here. And now we do not need to check the next time slot backwards, right? Because A is already scheduled at time slot 2. Okay, but if it happens that this is not empty, then what we will do, we will not break, we will go backwards, that is K equal to K minus 1. So this is how this algorithm works. So this loop, for loop, will iterate for all the jobs starting from the deadline of that particular job till the time slot 1, right? So it will search for an empty time slot. If empty time slot is found, then it will break and move to the next job. If it does not find an empty time slot, then it will search backwards till it reaches the time slot 1, right? So this is the algorithm for job sequencing problem. Okay, so now we will analyze the complexity. So the time complexity of this algorithm is order of n. So let us go backwards and see why it is order of n square. Okay, so here first is we have to sort the jobs. Okay, so sorting, there are total n jobs, so sorting will take order of n log n time, right? Then this is a constant operation, this is a constant operation, and here we have a for loop. This loop will run n times, right, for I equal to 1 to n. And then this is a while loop, right? This while loop is running from the number of time slots of that job till the maximum deadline for that job till 1, right? So in the maximum case, the deadline can be D, right? Deadline for each job, let it be D, and in the worst case it will be the maximum deadline, right? D max. Okay, so it means this entire thing, it will run order of n into D max, right? So this is there, here we have two terms, n and D max, right? And it is n log n. So now let us see why it is saying order of n square. Okay, so there we saw that it is order of n log n plus order of n into maximum deadline. Okay, so if we assume that the maximum deadline is almost equal to the number of jobs. Okay, the number of jobs, then it will be equal to n, right? So it becomes order of n log n plus order of n square. And out of these two, we can ignore this term because this is smaller. So we are left with this, which is the time complexity of the job sequencing problems algorithm, greedy algorithm. And the space complexity, as we are not using any extra space, right? So we can say that its space complexity is constant, right? So this is all about the job sequencing problem. Thank you.